morning, and welcome to today's webinar. This is the 25th webinar from Embedded Meetup. As you know, we are an NGO community, and one of our main activities is hosting webinars in the technical area of the embedded systems. Today's webinar is going to shed the light on the AUTOSAR COM module. This is something which is, I think, our first time to shed the light on a specific AUTOSAR module. An AUTOSAR is, of course, the de facto standard in the automotive industry. So if we have a single ECU, it could be co-developed by multiple suppliers, and each supplier could have a specific scope, and later then it could be integrated at the OEM side. How something like that could be done? It's by providing a common software architecture and development process for the software, and such a thing is very relied on in the automotive software industry. So today's webinar would focus on the COM module, which is responsible for the communication. And for that, we are lucky to have Muhammad Sada, who volunteered to speak about the AUTOSAR COM module. Muhammad, thank you for joining today.
Thank you. Welcome, everybody.
Muhammad, I just wanted to quickly mention your expertise in this area. You are a software architect at Elektrobit, Germany right now, and
Yes,
also,
exactly.
okay, and in the past you used to work to Avelabs Egypt, and also as an external to Bosch, Germany.
Exactly. Yes.
Okay, that's a very good experience. I just wanted to ask you quickly, how's the role of being an architect in Elektrobit Germany is different from the maybe usual software development from AUTOSAR point of view?
Okay, great. This is a great question. So, from my point of view here about the AUTOSAR architect, number one for me, he had to have the technical knowledge about the component he is responsible for. Maybe he's also responsible for several components. So the technical knowledge for me is number one, and number two, I can say how he can determine and identify the client needs. This is very important because both of these two factors are needed in order to get a successful software for your customers. And also, he could have the ability to create a possible solutions for the issues which is already existing in the software. And this is going to need from him the problem solving skills to create an existing to solve an existing and potential challenges which he could see during the development time. These three factors are very important for any software architect who could put a design for a component or a several component which is responsible for doing something to the customer.
Okay, thanks very much for the insight. And whenever we speak about an AUTOSAR component, shall we expect that you will provide information about the implementation also, or it's would be more like the interfaces, the required interfaces, and so on?
Actually, for I can say we can focus on the main concept of the com, how it's gonna working, and how you get your information maybe from the SWS. And I think the latest thing we can say it's okay, we can go to the implementation, but I think it's the main idea how to know what is a concept behind the com and what is the functionality of the com exactly, and how it's going to be maintained or being done in the runtime during the ECU lifetime. It's going to be our main focus today. Yeah.
Okay, and you've referred to the fact that maybe it's good to know that the SWS and also the other AUTOSAR documents should be a reference to this webinar.
Sorry.
You mentioned that one of the documents which is a reference for today's discussion is the
Hmm.
SWS. So
Yeah.
I wanted to highlight that our audience should refer also to the SWS and any other AUTOSAR technical document.
Exactly. It's mainly the SWS. Our all of our information today is coming from the standard specification. Nothing outside, nothing not there and here. It's gonna be the same SWS. But when I look to the SWS, I always see it have to be rearranged in a certain manner so it can help us to understand it better. And that's why I have my slides, which is already I arranged some concepts before going into this discussion, so it could help us to understand in the SWS what's happening there.
Okay, thank you very much.
Mhm. Welcome.
And I think that's all from my side. Please, you can start the presentation.
Okay, great. So, hello everyone. Welcome to the introduction to the com. I hope you have a good breakfast and you have your coffee also, because it's gonna be a lot of information today, and I don't want to waste more time. So let's start. Okay. So we are going today, this is our agenda, which I hope we could finish this actually. An introduction for the COM, first of all, and then we're gonna talk about the dependencies on the COM from other modules in the basic software. And then we're gonna start with the functional specification. It's mentioned like this exactly in the SWS. This is my main reference here. So we're gonna talk about the normal operations, the signal groups, large data types, also dynamic length signals, interface between COM and PDR, update bits, data sequence control, communication protection, and at the end, we're going to talk about the signal gateway. All of this is implemented inside the COM. And from here, we can go in a small introduction about where exactly is the COM in the basic software. As you can see in this slide, here we have our module, the COM communication here. And of course, this is a basic flow of any message coming in a bus. I'm going to talk today most of my conversation based on the CAN network, okay, because it's one of the most CAN protocol communication protocol used in our industry. So for here, if we have like a microcontroller and we have a bus driver, like the CAN driver receiving our messages in his hardware object, okay, and here maybe some hardware filter could take place. And from this point of view, when we receive a message, it go to the bus driver, CAN driver, and maybe we have multiple CAN driver on our microcontroller or our ECU. So we're gonna use here the CAN interface to interface all of this to the transport protocol in case of its like more data than one frame. In case of the CAN, we have more than 8 bytes. In case of the CAN FD, we have more than 64 bytes. And from this stage, we could go to the BDR routing, or if it's just single frame, we go directly from the bus interface, which is a CAN interface in our case, to the BDR direct. And from the BDR, it's just routing here, happening to give the messages to the COM. And there is also some gatewaying, but I'm focusing here in the routing. And from this routing, we reach to the COM, and from the COM, we start our mechanism. Okay. This is just a small introduction. This is a normal flow for any messages coming on the CAN bus, but I want to discuss more further about what is these messages. Okay, so when we have a frame received to our CAN driver, we call this frame is LBDU, data link layer BDU, protocol data unit. It contains the data lengths, codes, the normal CAN frame as you know, and it contains maybe some headers beside this data. Okay, and from here, when it's go up to the CAN drive, CAN interface first, okay, it's also the same name, data link BDU, okay, for this frame. And from this CAN interface, if it's having more than 8 bytes in case of the CAN, then we're gonna need to make a segmentation, unsegmentation, like collecting this data in one frame in the NBDU, which is called Network Protocol Data Unit in the CAN TB. And from this point of view, we collect all of the data for the message, and after that we forward this to the BDR directly, routing, and this is called here at this point of time we call it interaction protocol data unit. And from this routing we route it to the COM. Right now we have security stacks, we have another components like the COZ, and there's IBDM, and there's a lot of modules inserted and could be routed from BDR to these components and then return again to the BDR, and at the end they go to the COM. But I just want to give you a basic concept about what's happening, because my focus today is going to about this, the IBDU, which is in the COM. And this is a very important thing for me. And when it reaches to the COM, it updates the RTE, either it's a signal groups with a different mechanism. We're gonna understand how this is happening exactly. And from this point of view, we have the application at the end, software components, reading these signals or writing these signals. Okay. So let's forget everything right now and let's start simply. We have a software component in the application and it have, for example, a volt, okay, for a volt unit 8, for example, and it wants to send this volt unit into the communication bus. Okay, what's going to happen at this point? It's here the volt, I will call it signal 1. So signal 1 for me, it's presenting the volt. Okay, and maybe it have another different units. It could be signal 2 and signal 3, but also it may have some data which is a different data types, okay, having different data types, uint8, uint16, float, and others than that, okay, and they are all somehow related to each other, okay, so I want to send them in one group. At this point of time, we call this group a signal group. So the signal group for me, it's about some of the signals, okay, which have different data type, and they could also have, sometimes they could have the same data types, and we're going to talk about this, but mainly right now it's a complex data type and they are related to each other, and I want to collect them in one frame, the signal group, and then I want to insert this to the bus. Okay, but I want to differentiate between the signal which is going to be inserted into signal groups and the signal, the normal signal, which is going to be go direct to the IBDU. Okay, so that's why we call the signals which will be inserted into signal group a group signal. We make the name reversed. Okay, so for me, I focus on the second name. If it's a signal, then it means this is a signal like the signal 1 and signal 2. If it's a group, then it means it's a group of signals which is related to each other somehow, and they have different data types, or maybe they have the same data type, and they're going to be transmitted on the bus at the same time. Okay, so this is the smallest unit here is signals or group signal. Larger than this, we have signal group, and then at the end, all of this could be inserted in one IBDU. Okay, so the IBDU consists of signals, signal group, and each signal group consists of group of signals. Okay, great. Then let's assume right now we have two CAN controller on our ECU. Okay, and I want, of course, I'm not going to the initialization state and say, please transmit IBDU1, please transmit IBDU2, please transmit IBDU3. It's going to be waste of your time and waste of the software. So here we have a concept called IBDU group, which means I'm going to collect some of IBDUs together under one IBDU group, and I will come to the initialization and say, please, IBDU group 1, start. This means I'm telling the ECU, let's start transmitting this whole BDUs, okay? And this is gonna save our time. And by this concept, if we think together, this is how we use or what we use to implement the silent ECU. Whenever you have ECU, it's not needed anymore or no communication requested from this ECU right now. So why not we don't put this ECU in the save mode at this time? And to put this ECU in the save time, I can call the IBDU group and say stop. So I stop all of the communication, and maybe I will wait for a signal to be woke up again by our ECU. And by this way, we implement the concept of listening ECU, like saving the mode for our ECUs. Okay, for this, I suggest if we have CAN1 and we can't have CAN2, so I will collect the whole transmit messages on CAN1 into IBDU group and the whole receive messages for CAN1 into IBDU group 2, and the same thing for the CAN2. Why we need to do this? Because it's mandatory to put the IBDU group, all of the IBDUs under the IBDU group must have the same direction. Either they are all transmit or they are all reception to implement everything like this, okay? From this point, let's see what is the purpose of the COM, why we have the COM module in our ECU at all, okay? As you can see, all of these points, we're gonna talk about this today. First of all, the COM here is to provide the signal-oriented data interface for the RTE so the application can read the data. Okay, anyone want to send me some data? We have a break ECU, we have a transmission control unit ECU, and there's some data from there. It's important for other ECU, so it could be sending it to me, and I get the whole flow for the message until it reaches to the RTE, and the application can access this data from the RTE. Of course, there's a backing of AUTOSAR signal to be transmitted if the opposite direction, when the software components wants to send some data into a single IBDU, here it's being responsible by the COM to collect all of this data. Okay. unpacking and providing received signal from the IPDUs to the RTE and routing these signals from the IPDU into another IPDU to be transmitted. This is very important concept. We're gonna talk about this at the end. And we have some communication transmission. We're gonna introduce this right now. Replication of send requests. This is also a mechanism requested in the COM. Guarantee of minimum distance between the transmitted IPDUs, so there is no chaos could be happening on our bus. Okay, and monitoring of received signal, like the signal timeout, and filtering mechanism, different notification mechanism, also provision of init values, update indication, byte order conversion, sign extension, support of two different transmission mode, and signal-based gateway. And we're going to talk about large and dynamic IPDUs, and also the IPDU counter and replications. Okay, all of this is just an introduction. Let's forget everything right now. And I have example, which is very important in the next 5 slides. If you understand this example very good, it's from our daily life activity, you can say that you understand at least 70% of COM concepts. Okay, so from here, let's start. Let's assume that we have two companies, okay, company X and company Y. Okay, these companies are dealing together. If each week company Y buy some product from company X, okay, so each week company X has to prepare some documents for company Y and send them in a letter in order to say that everything and the payment is done. Okay, for example, employee from company X have to prepare every week receipt number one, okay, and he have also to prepare taxes information number one for the first week. Number one for me here, it indicate the first week, okay, and he have also to prepare the information about the product or about the payment which has happened, okay, and he have to prepare these documents every week. This is the first week and this is the first document, so he collected them in one letter and he add this letter to the post box of the company. Until here there is no problem, okay. Then we have a post car coming, forgive me for this shape of the car, okay, but this car is collecting the box from the post box here from the company every day morning, and then it takes this data or these letters to the other company post box, okay. And from this point, the employee from company Y will take the letter from here, will open the letter and gets his three documents. He makes sure, okay, this is a receipt for payment number one, there is taxes information for payment number one, and there is the information about the product which we bought this week. Until here, everything is good. Let's make some analysis to this picture right now. Okay, for me, if I think with you right now about this post box, of course, these post books have to have only the transmitted letters. I can't put here receive letters. Other than that, this receive letter will be taken by this car and I will not get it. And it was supposed to be with me. Okay. So at this point of time, I will collect this and I will call this post box as a transmitting group. We cannot add a receive letter in the same box that we transmit. Okay. And by this way, I will take this box in the opposite direction. This is a receiving group. I cannot put here any transmit messages. Okay. So this is a receiving group. And from what I see from here, he do some documents, he makes some backing to this document into this letter. I will call this also the backing process. And by the other way, this is the unpacking process when this employee from company Y open the letter and take the three documents. Okay. Until here, everything is good. Okay. Then um, what happened after that? Let's say the next week, we have here second receipt and taxes number two and information number two, and it's also backed in the same letter and it's being transmitted by the same way. And he here in the company Y employee, he received them in the same way. Take care, take care. In the second week, this employee cannot prepare the document for payment number three because he have to do this each week. So he cannot do this, or he cannot repeat this in the same week twice. Okay, and this concept, I will call it minimum delay timer for company number X, because he cannot do the same thing or transmit number two and number three in the same week. He have to transmit number two and he have to wait another week to transmit number three documents. Okay. This is the first concept, and take care if you understand right now what's meaning by minimum delay timer. It means that I don't have to transmit two consecutive times, okay, until a certain period pass. Okay, great. Then in the next week, actually, employee from company X, he tried in the same week, sorry, employee from company X, he tried to see and make sure in the next day after he put his data in the letter in the post box that the post box is empty. This means for him, okay, this means that the car of the post has taken the post box and moved. I don't care it's reached to the destination or not, but I care that my post box here is empty. So what is he is doing right now? He is monitoring, he is supervising the lower layers under him. He want to make sure that what he prepared it's already transferred. Okay, and at this point, if we can call this something, we can call it transmission deadline monitoring. This is for me very important to understand this concept, that the transmitter has to make sure from the super and supervise the lower layers under him that there is no messages received in his post and it's already transferred. Right now, he doesn't know this message is received or not, but he cares that these messages get out from his side. Okay, this is the second concept, transmission deadline monitoring. Okay, then in the next week, what happens? He prepared the document number 3 for the third payment and taxes and information, and he put them also in the letter and in the post box. But however, here um, it's it's there is no car. The post car was not getting this information, and it doesn't go out. Okay, and the employee from company Y started to worry. Where is our data? So he highlighted this to his supervisor and managers at the time is passed and we didn't receive taxes information number 3 and receipt number 3 and the information about our product. So his manager at this point could tell him, okay, let's wait for the next week, maybe they will gonna transmit document number 3 and document number 4 for the fourth payment next week. Okay, and this concept I will call here it's a reception deadline monitoring, because this guy from company Y was expecting to receive these messages and this letter in the third week. However, at this period of time he didn't receive anything, and this is very important concept. And what he do here, what is his behavior here, he went to his manager directly and he informed him, take care about this, he informed his manager about the I didn't receive the messages which should be received in the third week. Okay, this is a reception deadline monitoring. Okay, and from this point of view, in the fourth week, we are excited about what's happening there. He prepared the document number 4. Okay, the employee from company X, and he prepared everything and he put it in the letter. And here the post box comes. Okay, but somehow the things from third week was lost and it didn't receive to company Y. So company Y just received receipt number 4, tax number 4, and information about the product number 4 for the fourth payment. Okay, so the employee saw this and he was asking, okay, where's number 3? I didn't receive this number 3. And this is a third important, or the fourth important concept here, that there is a data sequence control happening from the COM, that it's monitor also everything. Okay, and no, I received number 2, then I'm expecting the next time I will receive number 3. If I didn't receive number 3 and I received number 4, I have to highlight to my manager, and my manager here is our software components. Okay, and this week, as we call it, like data sequence control. Let's switch right now to our AUTOSAR. Enough examples, and let's replate everything. We have our managers here in company X, software component 1, software component 2, our employees, our manager in these cases for the both of the companies, and they are preparing the documents. Our documents here called Signal Y, Signal X, and maybe Signal Group A. And we just explained what is meant by Signal Group. It's a group of signals which is really needed together to be impacted together and to be inserted together into the IPDU, because somehow they are related to each other. Okay, and we have Signal X and we have Signal Y. All of these documents right now is being inserted in the same letter, which is IPDU 1. Okay, but there is another employee in the company and we are dealing with a lot of companies, so we should have IPDU 2 and IPDU 3. Okay, and we should have a lot of IPDUs also, and we can say that this IPDU, which have the same direction as a transmit, it is actually the box here. This is IPDU group. So the IPDU for me is a letter. The IPDUs collected in an IPDU group. And when I say IPDU group start, then the post car have to transmit this. When I say stop, then the post car will not take anything from here. Okay. At this point of time, I hope everything is good. This is the backing. the process of backing, taking these signals to IBDU and collecting this IBDU under the same concept on the IBDU group. When I say IBDU group start, they will all be transmitted and go to their own destination. For example, IBDU1 will go to the company Y, which is requesting from there to read signal X and signal Y by software component 1 and signal group A by software component 2. Okay, so everything until this point is good. This is not how exactly the COM is working, because there is RTE, there is a lot of things in between, but right now we are just discussing the concept. If you understand the concept, software components, write signals or read signals, or maybe add some signal groups or group of signals, and all of this is bagged together under the same IBDU, and this IBDU is inside an IBDU group. This means for me that you understand the whole architecture of the COM from inside, okay? Then let's go more after the introduction to the dependencies that we have for the COM module. Okay, this is a COM module in the AUTOSAR, okay, and here's some modules which have to deal with the COM module, and we need to understand. To understand something, you need to understand what is required from this module, and what is its responsibility, what is its duty, everything about this module, okay? And from here, we're gonna see, for example, why the COM needs to interact with the RTE. For a simple answer, because it have to provide its own data to the applications, okay? And why the COM needs to deal with the BDR, because also when the application want to receive or transmit message, he need this from the COM, and the COM needs this to be done from the BDR, the routing table here. So the routing table, whenever he receive a message from the CAN interface or the CAN TB under this module, it will directly route this to the COM, or maybe other modules as we mentioned in the beginning, but right now we are focusing in the COM. Through the RTE, through the COM callbacks, or through the BDR COM underscore COM, anything gonna happen here to tell the COM, okay, we have received the message. And the COM will then update the RTE, and the application will then read this from the RTE. Okay, but you didn't tell us why is the ECU manager needed here. Oh, the ECU manager is a module which is responsible mainly on the initialization of our ECU. Okay, so someone must call COM initialization, and someone also must come at some point of time COM deinitialization. Who's gonna doing this? ECU manager is responsible for the initialization and the initialization of our COM module. Okay, so, and that of course it's known for us development error trace. It's to detect the errors during the runtime, which is good happening in the software. Okay, so this is have to be enabled somehow. And why we need the basic software mode manager, it's very important, as we mentioned at the beginning of the session, that we could implement the ECU silent mode by closing IBDU group and by starting IBDU group. Who is responsible for calling IBDU group starts and IBDU group stop? It could be done from the application. Yes, it could done from the application, but basically the current implementation in the market is going to use the basic software mode manager here based on some rules and some if conditions. We could say it's achieved, then we have a true action if this if condition is right, and my if condition, if it's achieved and the true action gonna be here IBDU group, for example, start, or IBDU group stop. So the basic software mode manager is using the COM in order to enable and disable and make some actions through the COM. Okay, the for the IBDU and the IBDU groups, of course. And here the COM manager is mainly used to maybe indicate, the COM have to indicate for the COM manager if there is some communication message which is important for the COM manager. State is it changed, okay? And this is actually, we are not going to see it in these slides right now, okay? So let's start for after the dependency, after the introduction, we have to start into the normal operation of the COM. From here, we're gonna pass by each operation could be done by the COM during the runtime. Okay. First of all, we're gonna start about the startup behavior. Okay. In the startup behavior, what we have the COM initialization, which should be triggered. And as I mentioned right now, it has to be triggered by the ECU manager in the initialization state of our ECU. Without calling the COM initialization, I'm not expecting, of course, as a COM module to be functional, okay, and to work as expected. Okay, what is happening really, man, inside this COM initialization function? We need to understand this. It's gonna be initialize 3 sections, most important sections for me. I'm not expecting you to know everything about them. You're gonna know them in the next few slides, but right now you have to know it's if we have unused IBDUs, okay, then it's going to be initialized with the com transmit IBDU and use the area defaults. This is a configuration parameter. You do it through the configuration tools, okay? And you have also to clear all of the signals with replacing them with a com signal init value if it's existing, and update bits. It have all to be cleared, and we're going to know what's the usage of the update bits also, okay? And at the end, of course, IBDU groups, as we talked, it's initially stopped. So it should be in the stop state in the com init and not even started. Okay, great. There is another functionality. It's happening here. It's not mentioned here. I think it came later in the next SWS, latest SWS, which was about, okay, if there is some IBDU is not belonging to IBDU group. In the first slide, we saw that we have a group of IBDUs, and they have to all be belonging to a certain IBDU group. But what happens if there is an IBDU is not belong to IBDU group? Is this allowed? Yes, this is allowed. But what happens to this? Who gonna start this and who gonna stop this? Actually, the com say it literally. It's gonna be started in the com init function, and no one can ever stop this. Okay, that's why we don't see this in our implementations in the market, because if this is you supporting the sleeping mode and it want to go to the power saver mode, then it's not logic for me to leave some IBDUs outside of IBDU group. How I'm going to implement the silent mode and there is some behavior like this? Okay, then at this point of time, we can talk about the communication modes, okay, which is how the IBDU is being transmitted, how the COM is transmitting this IBDU group. In order to understand this important concept, you have to know two things: that there signals and signal group inside the IBDU, okay, each one of them have a transfer property, okay, and this transfer property, it's indicating how is this signal affecting this IBDU. And for each IBDU separated among these signals or signal groups, it have its own transmit mode. Based on this value, there is a transmit mode for each IBDU, and there is a transfer property for each signal group inside this IBDU. There is a transmit mode evaluation happening here. How this is happening, we don't understand this. We're gonna see this by graph better to understand it. But first of all, I will discuss with you what is a transfer property and what is a transmit mode. Okay, for the transmit mode direct, for me it means that this IBDU should be transmitted when the application asks for this immediately. Okay, it should be triggered when I say okay, send immediately, then it will be sent. Okay, and in a periodic way, we say that we configure a periodicity for this IBDU to be transmitted every 10 milliseconds, for example. Then this IBDU by default will be transmitted every 10 milliseconds. And maybe a mixed transmit mode. For me, mixed means it's by default periodic. Okay, so it will be sent periodic, but I don't have any problem with the application when he requests between this periodic transmission to initiate a transmit. I will do this in between. It's okay. I will accept this. And if it's none, and this is means here for us, okay, nothing gonna happen to this IBDU. It will be kept as it is. And sometimes we use this when some issues happening. It could help us already in debugging to understand what is the error of the IBDU when I stop some IBDUs when it's not requested in this variant. For example, in your variant in a different among different variants in your project. So some of them are wanted to make a, let's say, super DBC between all of these variants, and he so variant number one wants message one, message two to be transmitted, but message three not, and the opposite in variant two and the opposite in variant three. So we use this num for these cases. Okay, and here we have the transfer property for the signals and signal groups, which means if I say triggered, this means that when the COM signal object dedicated for a signal value is updated by the application, when the application triggered COM send signal, this means trigger the signal. Okay, I'm seeing here triggers a signal to be transmitted, and he will trigger the whole IBDU, but it's not going to be happening like this because, as I told you, there is some transmission mode selection happening between both of these two cases. Okay, but triggered means for me when this signal updated in the COM, please trigger the transmission. Also, there is some triggered without repetitions. In some cases, we need to trigger with repetitions, and this happened at the initialization state of the project. Some cases we need our ECU to woke up all of the other ECUs, so it sends some messages different time with the same data actually, okay, more than one time, and we need this case to be triggered with repetitions. Okay, sometimes we need a trigger on a change, which means I tell the COM, please, whenever there is a something like, okay, change in the value or the length of the signal, because the COM doesn't understand what does mean by trigger on change. What does mean by change? Okay, it means by change that the value of the signal could be changed or the length of the signal could be changed. If one of these happens, he will trigger here on a change. Great. In the first thing, like we have also triggered on a change without repetition. So we have triggered on a change with repetition, triggered with repetition, and triggered without repetition, and triggered on a change without repetitions. Okay. And at the end, bending, which means do nothing, just wait until something happen. Let's right now combine all of these together and see what's gonna happen. Okay. If we have an IBDU contains some signals. Okay. If this signal is, for example, I don't care about the transfer property. It's bending, it's triggered on a change. Anything happening there, I don't care. Because if the transmit mode is periodic, I will send this IBDU periodically. Okay, great. And let's see the next thing we have here. If it's a direct transmit mode, okay, if this IBDU is a direct transmit mode, then what we gonna happen? If it's pending, this means that the value will be transmitted in the next BDU transmission, and the application will trigger the transmission of the signal, but there is nothing happens. It's gonna be just updating the COM signal object in the COM, and in the next main function, it will be transmitted when it's requested from the IBDU trigger transmit to be gone. Okay, and then we have a transfer property. If it's a triggered and we have it direct, then it's of course transmitted is initiated here. Okay, and if it's triggered on a change or direct and makes it, as I told you, here is going to happen at this case trigger on a change and direct and makes it together, one of them happening. This means whenever the signal is updated, an explicit IBDU transmitted is initiated at this time. Okay, and if it's triggered and makes it, for me this IBDU will be transmitted periodically by default, as I mentioned. And maybe there is a trigger coming from the application at some point of time, which is in between this periodic transmission. I have no problem. It will be transmitted at this case. Okay, take care about something. Direct and mixed transmit mode can be also repeated using the COM transmit mode number of repetition in your configuration, which means that I can send the same IBDU with the same data 3 times, 4 times as I wish, as I configure this value. Okay. And as I told you, we need this especially at the initialization to hook up the whole ECU then our bus. Okay. And to make sure it's already up. So if there is no request, if there is new request is received while there is a transmit repetition happening in the progress, what's going to happen at this case? This is a corner case. We're going to say it is the COM shall cancel the previous transmit repetition and starts the process the new quest. So the COM always take care about this, care about the newest data. Okay, he discards the old data. He care about the newest data, and of course, when we configure the number of repetitions, it's we have to say what is the minimum time between this number of repetitions, and this is going to be configured through your configuration by COM transmit mode repetition period. Okay, let's see how this mechanism really working. How is IBDU transmitted? I didn't get it until now. I didn't understand what's happening. So let's take an example. Okay, here's how the COM is transmitting each IBDU. Okay, we have IBDU here, okay, which contains signal 1, signal 2, signal 3. Okay, then please explain to me better what's gonna happening and how it's gonna be transmitted. I didn't get anything from what did you say. Okay, then signal 1 is coming from the application, and it was, for example, having a transmission, a transfer property, for example, bending. Okay, so and the transmit mode for this IBDU was periodic. What's going to happen at this case? At this case, the signal will go to the evaluation and will update at the same time the COM signal object in the IBDU. Okay, but it will go to the evaluation with the transmit mode of the IBDU. Then the COM-C. Okay, this signal number 1, it has a transfer property bending, which means for me, do nothing, just update the value in the BDU. But I can see that the transmit mode of this IBDU is periodic. Okay, and it have to be transmitted every 10 milliseconds. Then this signal, whenever it comes at 50 milliseconds, for example, it will just update the value here in the IBDU, and the BDU will be waiting until the next 10 millisecond pass, and then it will transmit this signal, this BDU, IBDU, total IBDU at all. Okay, so at this case, the signal is not affecting the IBDU, not doing anything, because the IBDU is transmitted mode periodically every 10 milliseconds, and this for me means it doesn't care, just this signal will update its value, and after 10 milliseconds I will send this IBDU in the main functions. Okay, great. Then the next thing we have signal number 2. If it's coming So we know right now signal number 1 is bending, but signal number 2, it's coming and it was triggered. Okay. And let's assume I'm going to say if the IBDU is periodic and if the IBDU is direct and if its IBDU is mixed. So we say it's still periodic, but this is was triggered. What's going to happen here? No effect. It will be transmitted at the same periodic. Okay. But if this IBDU was mixed, of course, it will be trigger the transmitting of the IBDU with the current data existing in this BDU. Okay. If the signal 1 come before this, update its value. If signal 2 comes after it, and signal 3 still have the init value and didn't update it yet, it will be transferred like this, the whole EBDU. Okay. But what's going to happen if it's direct? Of course, it's going to be initiate the trigger transmission also. So direct and mixed for me, it's going to be mixed by default. It's periodic IBDU transmitted. And whenever there is an request coming explicitly to transmit this IBDU, I will do this. Okay, to this signal for the signal itself. Okay. And the third one saying it's the same concept when we have something coming from gateway, and this is a concept we're going to talk about at the end of the com session. This is another functionality for the com. It's having also gatewaying. Okay. And it's the same concept that I told you. If the signal 3 is bending, is triggered, is triggered on a change, maybe it's triggered on a change and both of these signals are bending. So I will check here if the last valid values I received was 1. If the next value is 1, there is nothing gonna be happen. If the IBDU is at this case periodically transmitted, okay, until the IBDU periodic comes, and then it will be transmitted. But if this here trigger on a change and the IBDU was periodic transmitted, then at this time signal 1, signal 2 bending, I don't care, they just update their own values in the IBDU. And then signal 3, when the update signal is coming and it was value changed than 1, it was for example 2, then a explicit transmitted for this IBDU will happens. Okay. Great. Then this is happening inside the COM. The evaluation of transmission mode selection. It's happening inside the COM. Okay. Then let's go to see the concepts which the COM is providing for us during the implementation. And you can think how to use this concept in your current project or current implementation if you are doing it. Okay. Then the first concept what we're going to talk about is replication of signal transmission request. What's mean by replication of signal transmission request? It means for me that what happens if my transmission is fail? Okay, let's say I just initiated BDR com transmit for certain signals and it doesn't happen anything, nothing happens. Okay, what's gonna happen here? We have something called com retry failed transmission request. Uh, it must be not set to true because this is a retry failed request. Okay, and I'm going here to make sure that when I trigger a transmission, the confirmation returns here, everything is okay. Then I'm not going to do anything. But what about if the confirmation here returned not okay? Let's read this. He's saying for you, the first thing you have to make sure that the com retry failed transmission request is not set to true. And we will say why we need this. And if the com transmit mode number of repetition is 0, then the com here at this case shall invoke the BDR com transmit for the IBDU if it's direct or mixed, not none or at all. Okay. And one time regardless the confirmation. So he didn't care. He didn't care if he sent this message, okay, and no transmit confirmation, say okay, no even say okay. He doesn't care about anything. He just trigger this and that's it. Okay, then let's say if the end time transmission is requested in transmit mode after a cyclic transmission of mixed transmit mode with a bending confirmation, at this case, it seems that it's complex to understand this, but simply you initiated a transmission of a message and you were waiting the confirmation for this message. And you were surprised that there is in repetition cycle configured for this message. What's going to happen by the COM? The COM will see that this confirmation, because the confirmation didn't receive, for example, you have 1 transmit and 3 repeating transmit. He will consider that he have 4 minus 1, which is 3. And this is by logic, you gonna get this, okay? So he will request to transmit H3 until the confirmation is returning, okay? And if transmit mode is fixed and in time transmission request configured at this time, we can say that we should count the cyclic time as end time transmit mode to avoid overlapping. So if it was a mixed, and mixed means it could be sent as periodic and it could be sent as a direct. And we say it's by default periodic. Then what's going to happen if you configured repetition for a periodic signal? The COM will consider the cyclic time as at n time of repetitions. So he will make them at a one. So no overlapping could happen. If it's periodic every 10 milliseconds and you said repetition three times, then he will consider the first one at the first 10 milliseconds, 20 milliseconds, 30 milliseconds. He just combined both of them to avoid the overlapping. Okay, if we have a transmission deadline monitoring timeout before the end time transmission is complete, the COM shall not initiate further transmission. If you have a repetition configured for this signal or this IPDU happening here, then the COM will not do more further transmission whenever the reception deadline transmission deadline monitoring finished. As I told you at the beginning in our example, transmission deadline monitoring means for me that I'm supervising the COM is supervising the underlayer lower levels. He have to make sure that this message go out from the ECU in a certain time. If it doesn't go out in a certain time, he will discard the other and he will not complete for the repetitions. Okay. Notice to avoid some burst in the startup, we have some time offset can be configured by IBDU special only for startups. There is a startup offset time which you can configure in your configuration tool, and this is really exists. We have some time out, for example, for the transmission deadline monitoring at the normal transmission, but there is a first time out there to be configured at the beginning of the ECU lifetime because, as we know, the initialization may take some time more than normal running time. Okay, that's why we could increase this timer at the beginning a little bit so to avoid any issues, and then it returns to the normal time behavior in the runtime itself. Okay, and if transmit mode changes lead to a start of transmit mode mixed, okay, by sending a triggered signal or and the transmit number of repetition is configured greater than one, at this point then the triggered one plus the number of repetition will be transmitted to the BDR. Okay, this is a normal thing. You have a transmit mode triggered, okay, transmit mode by sending triggered signal, transfer property signal for a signal, and transmit mode here mix it. Okay, so the BDU is transmitted periodically, and you have a direct request coming by transfer signal. It's triggered, okay, and we have a number of repetitions. Then how many number of transmission gonna happen? It's the number of repetitions plus one the current transmission. Okay, great. So the second concept, retry failed transmit requests, which we set there to false. Why we set this here to false in the replication? Because if it's this true, okay, and the signal fail, he will transmit it. And we don't need this because we have a number of repetitions gonna happen. Okay. At this time, we have a tray failed transmission request. If it's set to true and the video com transmit returns okay, e not okay, for example, then the com module shall invoke here the video com transmit. So explicitly, you send a message, you send your IBDU, and you get from BDUR com transmit, it returns e not okay. This means that even the first transmit step doesn't take place. Okay, then the COM will invoke this again. How many times the COM need to be invoking this? It's gonna be specified also in your configurations. And how he can invoke this again, he will wait for the next command function to invoke it again. Okay, for the number of times which you specify in your configuration. So this may lead to multiple retries for the same failure transmission requests, which should not affect the transmit mode change and repetition for the period. Okay, so also, if you have it as a periodic transmitted IBDU, the COM will not consider what's happening when it's failing as anything. When the BDUR COM transmit returning okay, the COM will start his periodicity and his timers and everything at this point of time. Okay, except for one timer, the transmission deadline monitoring timer. It's always started from the BDUR COM transmit because, as I mentioned to you, this timer is used by the COM to monitor and supervise the lower level under the COM. So if he just trigger BDUR COM transmit and there is something happened wrong and it didn't return okay for me, then at this time it's gonna be needed for me to stop the transmission if this timer is end because there is some issue there. Okay, great. Noticed if the COM failed transmission request is set to true and the transmission here deadline timer occurs, timeout occurs, the COM shall expire any pending transmission for this IPDU as we mentioned right now. Okay, great. Then, and at the end, also the cycle timer for cyclic transmission shall also start with the first transmit attempt. Okay, let's go to the next one. We have something called signal invalidation. Okay, what's mean by signal invalidation here? This is it's simply we have a transmitted ECU and we have a receiver ECU here, and one who transmit the messages, it transmitted data from the software components like some signals, very important signals, but at some point of time they have also their own mechanism in their own ECU to test. It's not logic for me to see some volt with negative value. Okay, it's not logic for me to see some data in a negative value, for example. Okay, but I saw this in my implementation. What I'm going to do, and I have to transmit this data into the other side. Okay, this is invalid data value, and I know that it's invalid data value, but there is a periodic transmission, and I have a commitment here to transmit this message. So I will agree from the beginning with the receiver ECU. Take care, take care. If you received from me this value, it means that I'm not able to provide you with the right value right now because there is some fault in my side. Okay, and this is how we use the signal invalidation. If there is the COM module at the transmitter side agree with the COM module at the receiver side, I'm going to send you, for example, 0 whenever I have an invalid data. Then the receiver side, when he receives this signal and make um, I'm back for this, okay, I'm backing for this, it's gonna check this value. If it's 0, then from the receiver side, I know what's happening, that the issue is from their own side. Let's imagine if this concept is not there, what's going to happen? I'm going to receive a wrong value and I don't know that this is a wrong value, and it's going to be crisis in the software. Okay, so by this signal invalidation, as we mentioned, the COM shall provide the possibility to the sender to indicate if it's not able to provide a valid value for a corresponding signal. Okay, and the AUTOSAR COM module here shall define this invalid value at the receiver side with something called, and transmitter side also, with something called COM signal data invalid value. Okay, COM signal data invalid value. If I put here any value, then the COM will monitor this value when it's received. It indicates for him that this signal will be a false signal, and let's see what's going to happen. Is he going to accept this or not? Okay. Transmission of invalidation. This is from the the part of the transmission ECU. By calling the invalidate signals or invalidate group signals, COM module shall perform internally COM send signal with this sync with COM data signal in the invalid data. Okay, whenever you send signal, you call directly COM send signal, but whenever you call COM invalidate signal or COM invalidate group signal, he will add the invalid data value before calling the COM send signal. Okay, and then he triggered the COM send signal. And at this time, the COM transfer propriety and COM transmit mode, of course, will determine how is this gonna be transmission, the normal transmission mode evaluation, which we talked about right now. And at the reception, this is the most important thing. What's gonna happen here? What is the reaction of our ECU here? If he received this data for a signal or a group signal, and it was configured to one of these two things, we have an action to be taken. Either you choose, you tell the COM, please notify the application via an RTE, okay? Or please replace it. But what value he could use to replace it? He could replace it with the COM signal init value, which is specified in the configuration at the pre-configuration time. Okay, so if we receive this value wrong, I will do one of two things. Either I notify the application and then I will discard this value. I will not take it into my consideration, and uh, I will notify the application as we mentioned. But if it's configured to replace directly, I will not take the application, tell the application anything. I will go directly to replace this with the normal or the init value there. And it could also take here, you can configure actually the notification here. Okay. Then let's go to the next part about, we talked about this at the beginning also for our examples, the IBDU groups. Okay, what's mean by IBDU groups? How we handle the IBDUs, and we say that our post box in the company, which contain all of the messages, it have to have the same direction because this post box is for transmission, okay, or reception, as you wish, but you cannot put the transmission and reception at one place. Okay, so for me, the IBDU definitions, they are four definitions. I depend on them. Any IBDU can belong to IBDU group, but it's not must. As I told you, if there's an IBDU doesn't belong to IBDU group, it will start initiated to be transmitted directly in the com-init function, but it will never stop. That's why we don't do this. We always organize everything under same IBDU group, okay? And the maximum number of IBDU groups which you can configure, it's pre-compiled, defined by your tools, and the IBDU, if it's started, um, uh, when the IBDU is started, it is started when the IBDU group, which it belongs to it, it's started. As I told you, I can come and say from the application, com IBDU group one starts, or from the basic software mode manager, I put a rule whenever this condition achieved, please start these IBDUs. Okay. Great. And the IBDU groups, as we mentioned right now, also, it may only contain the IBDUs of the same direction, either the transmission or the reception. Actually, the configuration will not allow you to put some transmission and reception at the same IBDU group. It will give you an error at this point. Okay. Then further, it's expected that the complete state handling of IBDU groups is happening outside of the COM. As we mentioned, it could happen in the application, it could happen in the basic software mode manager, anything. Okay. And this is an example for this. And any IBDU which is not assigned actually to the IBDU group, the COM will start this in COM init, and such IBDU can never be stopped. Okay, so don't put this in your software. And let's talk more details about this. What's going to happen when we start the IBDU, when we stop the IBDU groups itself? Starting the IBDU group by default, before this step, all the IBDU were stopped here. And when we call IBDU group start, all of the group will be started. Then what's going to happen? The COM shall initialize the following attributes for each BDU in this IBDU group. First of all, initialize the COM minimum delay time. As I told you, the minimum delay time, it's only in case of transmit mode is direct or mixed of the IBDUs, which is going to be transmitted, because it's we don't allow two consecutive transmission happening until sometimes pass. Some certain times you can actually do this in the configuration, and we talked about this at the beginning. Minimum delay time, when the employee cannot send number two receive, number three receive in the same week. He have to wait a certain time before he prepare the second documents. Okay. And restart all the timers, the line monitoring timers, everything gonna be restarted, and we will return it to the COM first timeout initialization, because we are in the initialization state. Then we need more timeout to avoid any issues could happen in the initialization for transmitting or reception, and cancel all the line time monitoring timers. Of course, as we mentioned, use the com timeout, and all the update bits shall be cleared. We can understand what's meaning by update bit in the next few slides. Reset any occurrence filter which is configured. Okay, accept set the IBDU counters to 0. We're going to talk about this also, and actually accept all of the IBDUs which a com IBDU direction configured to receive at any next IBDU counter. As we talked about at the beginning, whenever the employee transmits something to the other employee from company Y, for example, the first week the company Y was not knowing how the mechanism, how is the counters, what is happening there, but it received the letter from company X which contains receipt number 1, text number 1, information number 1. But the second week they were expecting to receive number 2. And the third week they were expecting to receive number 3. And what's happened when number 2 came after this number 4? The employee from company Y raised this issue to his manager. Okay, and this is the same thing here. The COM at the beginning shall accept any received IBDU with any IBDU counter, even if this IBDU counter is 5 and it's not 0. But he will expect the next counter to be 6. You get this, okay? And uh, according to this, there is something happen also attributes to this IBDU, like the data of IBDU is defined, initialized according to the signal value, init value, for example, and the shadow buffer for the signal groups. We're gonna know what is meant by shadow buffer here also in the next few slides, and also the com transmit mode periodic, if it's periodic or mixed, and the offset of this transmission, what's happening there. Okay, this is in case of a starting. Let's summarize all of this. We have here at the receiver side, when the starting happening of the IBDU group, he will initialize all the timeout equal to true, com signal first timeout, com signal timeout. Normal reception gonna happen for com receive indication whenever we have a message, or maybe it's larger message, so com TB receive indications, and normal reactions on any receive signal or receive signal group. He will not take care about the counters right now, okay? And he will forward it directly to the applications. No transmit timeout notification until next send. Okay, this is for at the transmission side, and for periodic transmission, it must start at 0 because I'm the transmitter, so I am the one who have to start everything. Okay, normal reactions on COM-send signal, COM-invalidate signals in case you have a valid value at the initialization, and COM-send signal group also, and there is normal reactions on COM-trigger signal to transmit to trigger the signal to be transmitted. Okay, this is actually as scenarios which could happen. I think this is too advanced to read it right now, but you can have the slides. I can share it after the presentation. I need right now to talk about the stopping of the IBDU groups. Okay, a call to com IBDU group stop um, happening. It could happen from the application. It could happen also from the basic software move manager, but it will happen outside the com most definitely. Okay, then it will disable the transmission of an IBDUs, for example, all IBDU group under this. If this IBDU group was for transmission, it will disable the whole transmission. And as I mentioned at the beginning, this is how we implement the listen only mode, disable transmit of the ECU. All of IBDU group containing a transmit IBDU will be stopped at this case. And then we could wait until some message come received, and then we woke up on this message. Okay. And for this also at the receiver side, we're gonna stop the receiving deadline monitoring because it's gonna give me an error if it's still working and I stop the reception of my IPDUs. Okay, and no action on com receive indication to the RTE, no storing of the IPDU gonna happen. Every literally service the com will provide it, it will gonna be stopped. Okay, and from the transmitter side, it's gonna be the same. It will ignore any com transmit confirmation, any com trigger transmit, ignore the behavior of any transmission deadline monitoring, but in calling com send signal group, com invalidate signal, uh, send signal group array maybe. Okay, all of this gonna update the internal buffer. However, the return will be still here, com service not available according to the SWS. Okay, so you know that your signal is updated in the buffer, yes, but there is no service available because the com is disabled. Outstanding transmission request will also be cancelled. Okay, at this point of time, let's talk about the signal indication. Okay, the signal indications, which means whenever the receiver have an IBDU and he extracts the signals from this IBDU, what's happening here, how he do this. Okay, since any software system right now, it's supporting both. Either it's interrupted driven, so I have some signal coming, I raise interrupt, I do everything I want, or the bool system, which means I handle everything in my periodic functions, which is like the main functions for the com exam, for example. So right now we can configure signal indication to take place within two modes in the com, and you configure this in the configuration time, okay, in your configuration tool, either in the you put into the COM IPDU signal processing parameter in your configuration, it's immediate mode or deferred mode. Which one is better for you? Which one is suitable for your design? You have to choose this. What's mean by immediate mode? It means for me that COM module will invoke the notification for included signal and signal group within the COM receive indication, which is coming through the interrupt context or COM receive TB receive indication. So anything gonna happen in the immediate mode, I will inform and update the RTE in the interrupt context. But in deferred mode, I will do something. The com receive indication come, or the com TB receive indication come in the interrupt. I will make it raise a flag and leave the data in a buffer there, okay, in the same buffer as it is. And then when the com main function comes, he will go to their own buffer and he will read this data and he will update the RTE. Let's see this most, it's going to be most interesting to see this in a graph, okay? Immediate mode and deferred mode. As we mentioned here, here's the BDR, there is interrupted coming and say, in this interrupted call, the com receive indication, it tells the com, hey, I have a signals and signal group coming for this IBDU, and then the com will take this copy to the RTE, as we mentioned, making the unpacking process, okay? And then when he finish, he will return back to this interrupt. At this time, the interrupt context will be larger. And then here, this is according to your design, is it allowed you to do something like this or not, okay? The most used way in our automotive market, it is a deferred mode. Like, okay, the com receive indication comes and he set a flag for the com, and then when the com main function come here, it check this flag. If it's raised, if it's raised, then it will take all of this data and update the RTE. But take care, the interrupt is ended here. So it will come here and set the flag, interrupt complete end, and then the main function, it will check the flag. If everything is good, I take the data, I read the data, I put it in the RTE, and that's it. Okay, then the application can access this data. This is how the two ways which is used by the COM in signal unpacking to take the data. Okay, great. So this is something good, but it cannot be good like this. There is no ideal case for us. So what we have to do, we have to monitor the whole operations. At the COM module, I'm not going to just take and put, just take and put. It's not like this. I have to monitor everything. I have to take care about any faults could happen. And from here, we introduce our deadline monitoring timer. It's the most important timer in the COM module from my point of view. It's a very powerful timer, and you can use it a lot in knowing a lot of issues in your software. The purpose of the deadline monitoring timer, it's to monitor the transmission and reception behavior which is happening from the COM. Okay, great. But what is the parameter used to configure this timer? We have something called COM first time out, as we mentioned, and COM timeout. The COM first time out is used in the initialization state. So as we know, the initialization could take more time, and the COM timeout could be used after the initialization in the normal running time, because it's not like the initialization timeout, of course. Okay, great. So I'm not going to take about the cases how to omit this, how to configure this. This is related to the configuration. If you are working in the field itself, you're going to know this by document easily, but I'm going to take about the concept. For the reception deadline monitoring time, in case if we have a periodic transmit mode for IPDUs, we know that this PDU should be received every 10 milliseconds. Then I will put my reception deadline monitoring based on this value. So what is the tolerance my project or my design allow me to accept that this signal is not be received? For 10 milliseconds, yes, it should be periodicity, but you can add a tolerance at 20 milliseconds. So if I didn't receive this signal maximum 20 milliseconds, there is an issue and fault happening. What are you going to do? And you can also put the reception deadline monitoring the same like the periodicity as you wish, according to your design. Okay, then the COM receive data time out actions which will be taken when a message is not received in this time out configured, one of the three things. And you can set this through your configuration, com receive data timeout action. Either you choose to replace, okay, this message is not received this 10 millisecond, I will replace its value. Okay, but what is the value which I could add? You're gonna configure this as at the pre-configuration stage. You add a value in the configuration, or you leave it empty and he will take the com signal in its value at this case. Okay, by doing replace and adding a value in substitute, he will replace with the value which you added in com timeout substitutions. Okay, and if you add none, this means for the com keeps the last valid data. Let's assume it was the first time and there is no last valid data received. What's gonna happen at this case? He will gonna keep the com signal init value, which is initialized in the init phase of our ECU. Okay, by the com init. Great. So this is the three stages which happen about this here. Okay, and if we go to the more details about this in the large IPDUs, what's gonna happen if it's not received, it's going to be the same concept actually, but how to close this timeout. If you put 0 in the configuration, how to enable it is you put the value. Of course, this is something you're going to know for this. But how the implementation, what is the API is called in order to start this timer? Something called in com underscore enable reception deadline monitoring, com underscore disable reception deadline monitoring. So this is the APIs which is called internally in the com when you trigger the IPDU group to start. Okay, great. For the other side, the transmission deadline monitoring at this case, here, this is the opposite direction. As a transmit, what do I have to monitor? Do I have to monitor it until it reaches to the other side? No. The transmission deadline monitoring is used only to supervise the lower layer under the COM. So the COM will initiate the transmission, okay, and he will wait the transmit confirmation. So by default, when the transmit confirmation comes to the COM, he know that this message is right now in the hardware box. He leave it and he doesn't care about what is next happening, okay. And by this case, we can say that the transmission deadline monitoring is only supported for the IPDUs, which support the transmit confirmation. Okay, so if the COM module is not supporting the transmit confirmation, you cannot use this concept. And it's very important because some of cases we see some issues in our ECUs that the messages is configured and everything is good, and somehow it doesn't go to the bus. We cannot see this on the bus. So this is gonna be very important indication for you to know that there is something happening wrong under the COM. And if everything is here correct, then you know that something happening wrong above the COM. Okay, great. And at this case, for the transmission deadline monitoring, what we have here, we have when the COM transmit confirmation, as we mentioned, it's received, and this is a special cases here. We're going to talk about it. Uh, it shall cancel when the transmit confirmation come. It shall TDM shall be cancelled, so the transmission deadline monitoring. But what's going to happen in case of configured IBDU with transmit mode none? COM shall start the TDM above the start of this IBDU group in which it belong. This is a case. And what's going to happen if it has transmit mode none and another transmit mode exists at some point of time? So here it will disable the transmit mode none when the transmit mode none is active. Okay. And of course, only the COM module shall reset this TDM timer when a successful again transmit confirmation received. Okay, great. Then if a timeout happens, what's going to happen? There is a timeout notification error for the contained signal and signal groups. Regardless any reason, this timeout notification will be triggered to inform the application there is something happening wrong under the COM. And that's why we say it's very important to use this mechanism when you try to debug and know why the message is not getting to the bus from your ECU. Okay, great. And here the what's going to happen in with different cases when you use this mechanism, transmission deadline monitoring, for transmit mode number of repetition. Okay, this is special corner cases. You can read this, it's easy, and I will provide also the slides. Okay, then let's go to the next um, slides. Okay, then what we have here, we're going to talk about very important concept in the COM, signal groups. We talked about signals. Let's see the signal groups and types of signal groups. First of all, the signal groups is here to introduce the concept of complex data type. When we have a complex data type like UNT8 signal, float signal, UN16 signal, and they are not the same data type to be inserted in the COM. Do you think it's going to be easy for the COM to just go and, okay, with first signal, it was UNT8, then I need to take 1 byte. Second signal, it was UN32, then I need to take 4 byte. It's not efficient. It's take more time from the COM to check about the data type and everything. That's why we added the concept of signal groups at this point of time to make it more efficient. Signal group is a group of signals which have different data types, and in order to achieve the consistency of signal groups, we use something called a shadow buffer, which means it's a buffer between the RTE and the COM. This buffer, the COM update it first, and then in the main function, it's gonna be updated in the RTE itself. When you call it or trigger it from the application, the RTE you're gonna read the things from the RTE. Okay. So what's happening here? How this is being done? The RTE can trigger explicitly COM send signal group or COM send receive signal group, and the synchronization is performed actually automatically. The signal group array, when you say COM send signal group array or COM send receive signal group array, this is another concept. We're gonna see it right now. But right now, let's focus on the signal group by calling the COM init, as we saw at the beginning. I told you you will know this in the few slides. It's the shadow buffer of group signal on the sender side. It shall be initialized in the COM init. Okay, but it's not expected from any software component to read any signals before calling the COM receive signal group by the RTE. This is most important thing because you always get garbage data. Okay, and in the transmission, if COM send signal or COM invalidate signal is called for a signal which is belonging to a signal group, okay, the COM first will update the shadow buffer of signal group, okay, and will stop at this point. He will not complete because COM send signal. It means that the software component want to write something from a signal group, okay, and he will update something in the signal group, but the whole signal group is not updated yet. It's going to be triggered to be transmit when we have COM send signal group. Okay, so for example, I have signal A, I have signal B in the transmission side, and both of them, one is UNT8, or the other is float, or the other is UN32, anything. They are different data types right now, and when they are belonging to the same signal group at the same time. So how this mechanism is happening to transmit the signal group? First of all, software component 1 will call ComSend signal A and will add the value of signal A. Then the shadow buffer is updated, and send signal B will gonna be triggered from software component B. Then at this point, the shadow buffer will be updated for signal B. Everything is good. The buffer is filled. Then we call send signal group, and the whole signal group is updated in the IPDU, and the normal flow will come after this. Okay. And at the reception side, what's gonna happening? First, the RTE triggered receive signal group. When he received the message, received the IPDU, he takes the signal group, he added it into the same shadow buffer, and then the signals being read from the application when we say receive signal. So the RTE signal A and software component 2 can read the same signal by receive signal B, for example, another signal in the same signal group. Okay. All of the notification which happen here are configured on the level of the signal group. So nothing gonna be configured for the group signals. Okay, great. At this point of time, let's see this more. What is gonna be configured by group signal and what is gonna be configured by signal group? I would like also to remember you that the group signal is like the signal and it's inserted in the signal group. Okay, so an update bit, it's just gonna be for signal groups, signal notifications, receiver side, sender side. It's also in signal group concept. Sender receiver side for timeout notification or error notifications. It's still for sender side. Error notification, it's only for sender side, not for the receiver side, of course. And validation notification for the receiver side, and it's signal group. Data access, both of them you can access them from your components. Data access sender side, also from both of them for the receiver and sender. And data filtering, it's only happening based on the signals or the group signals, because both of them are the same concept for me. Okay. And data filtering, it's not here and here. Okay, great. So transmission mode selection on sender side, it happens on the base, as we know that transmission mode, it's of course evaluation happening between the transfer property for signals or group signal and the IPDU, but not for signal group. Okay, again, I would like to highlight the difference between group of signals, group signals, and signal group. Group signal, it's the same like signal, but why we name it like this? Because it's an indication for us to know that this is gonna insert it into the signal group, not the IPDU directly. Okay. Then another concept from the signal group, they think again, and say, since this way is efficient, what's happened if someone or some application or some software component, they have uh, group of data and they are related to each other somehow, and they want to put them into signal group, but this data is not complex data, they are all the same, maybe they are all uint8. What's going to happen at this case? They implemented this concept uint8 array based access to signal group. So we have here the signal group at the uint8, whole of the data is uint8 and they are collected together in one array, and this array is going to be triggered to be transmitted by send signal group array or receive signal group array. It's only uint8, and in order to configure this in your software, you have to configure the group uint8 array group access in your configuration at the time of the configuration, of course. Okay, send signal group array access, yes. And the serialization of this composite data is done by somehow the is making some serialization of this data, because since it's uint8, so it's more efficient. He know that he will take uint8, uint8, uint8. He will not try to ask anything about the data type before he take it. Okay, this is more efficient for the Okay, so only at this case, fixed data type for composite data defined, signal group mapped byte aligned to the IPDU, and signal groups are not intermediated by other signals at all. Okay, you cannot put some of the signal group at the beginning of IPDU and the other at the end. It's not gonna happen. Okay, and in a case of signal group array access is defined, then at this case, the calling of these APIs for this signal group is not supported anymore. Take care about this. Send signal, receive signal, send signal group, receive signal group. You cannot call this for the signal group array, uint8 array based access. Okay. Then signal group is as we mentioned, it's having some filtering mechanism, like always, like never, like masked new equals. What's mean by filter mechanism here? It's always means always receive this masked new equal. You mask it with a value configured in your configuration. If it's equal something, then you're gonna pass it. If it's not equal this something, you're gonna discard this message. And the same thing for each kind of filters. Okay. And for this, we have here the basic functionality of the AUTOSAR transformer, which is used at this time to read and linearize and to transform the data from this uint8 array to our COM here. At this time of case, we say, okay, since it's uint8 and it's easy to be captured as it is, we just know the number of bytes, we know which signal group to be bagged, and we take it directly. Okay. At this case, do you think we need shadow buffer? No, we don't need shadow buffer because it's not a complex data type. It's easy data type, so you don't need here at this point of time shadow buffer. Okay, because all of them are fixed data type. Great. In the initialization, it's initialized, of course, by com init, and which also using the com signal init value. Okay, for all of the included group signals. And whenever you transmit it, you call com_send signal group array since through the RTE, and then you iterate array by data pointer will be there to represent your data and will take it to put it into the IBDU directly. And when you do the reception, you do the opposite thing, com receive signal group array from the RTE, you get everything, and the application can access it. Okay. Then what we have another kind of IBDUs. We talked about the IBDU, all of these things that we talked about right now, it was for the IBDU normal. But what happens if we have large IBDUs? Okay, at this point of time, maybe the IBDU is larger than 8 byte on CAN, larger than 64 byte on CAN-TB, on CAN-FD, okay? Then at this time, here the transport protocol will interfere. He will collect the data, he will back the data to the comms through the PDR, and then you handle this thing. How this is gonna happen? Okay, since the com is abstracted about any communication bus down there, so it doesn't know what are you using exactly, and the TB here responsibility is to get all of the things. So the com will not be able even to detect or prevent too large IBDUs, which is being sent on a bus protocol or received, because as we mentioned, it's bus independent, so it will use the BDR interfaces as usual and put the data, and from BDR, either you choose to treat like or to deal with the CAN interface or with the CAN TB, for example. Okay, but it's allows the maximum length of NSDU standard data unit here of underlying TB can be used. And since most of our project allow the maximum buffer for the CAN TB, so it could reach to a very big number actually. Okay, how the transmission is done for this large signal IBD, we need to understand what's happening here. First of all, you trigger the BDR com transmit to initialize the send request, initiate the send request, and then you have with a TB coming, okay, one or more callback to come copy transmit data because it's not one frame. So he will go and take one and take two and take three, and until everything is being backed in the TB, then everything is sent at this point of time. You will get at the end com TB transmit confirmation. You used always to see com transmit confirmation when it goes through the interface, CAN interface, okay? One frame, single frame, you don't need TB at this case. But whenever you use TB, you're gonna see com_TB transmit confirmation instead of transmit com_transmit confirmation. Okay, great. And then this callback comes to indicate for you at application as a com here also that the transmission is successfully. Okay, after a successful initiation of transmission by calling these things BDR com transmit, the com shall not modify the data of its internal transmission buffer of this IBDU unless the com is notified by either successful transmission, it happens, so you can modify this data. So this is a logic concept. You cannot modify the data after I trigger the transmission. Okay, you only allow to modify the data when the transmit confirmation is received back. Okay, all of the since all of IBDUs are actually static configured, then the com are not surprised at the runtime. We know everything before the runtime. Since the complete memory for IBDU is already reserved, even for the large IBDU from the runtime, it's not gonna build if you exceeded the stack. Okay, you're gonna see this before even going to the runtime. In case of large IBDU is transmitted currently, and the same IBDU is transmitted periodically, then the com shall skip the additional send request and report an error time like a skipped transmission, and this may cause delay in the next transmission cycle. If there is a currently transmission is happening and it was periodically and it doesn't finish until the next one come, he will skip the current send request and uh, 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 next send request, and this may cause delay in the next transmission cycle, and this is causing a problem for large IBDUs. Okay, at this point of time, we go to a reception side. In the reception, it is opposite direction at all, start of reception, triggered. Then we indicate for the com, okay, there is a big message coming, and then com copy received data, go and copy this message one by one until the buffer is received as a total, and then we deliver to the com at the end com tb receive indication as an indication that you have received your data. If it doesn't return you okay tb receive indication, this means that the com shall treat these signals with a large IBDU exactly like invalidated signal. He will add invalidated value at this point of time. Okay, and um, it's the data in this buffer will be overwritten gradually when you receive this data. Okay, so if it's not received, the whole data is not received and TB returned not okay, then he will treat it as an invalid data. Either he notify the application and or he replace the data with init value. Okay, great. For these things which we talked about, this was about the large IBDUs. Right now we could see another thing called dynamic lens signals, how it could be dynamic for us. First of all, there is nothing called dynamic in our field. Everything has to be known in the uh, pre-configuration time, of course. But what I mean here by dynamic, I mean like I can say to you simply the signal size is 16-bit, okay? But this is a maximum size. It could be received at 8-bit, 9-bit, 10-bit, but the maximum size is 16-bit. But pre-configuration, you know the maximum length which could be reached with this behavior, okay? And in this way, the signal can be the signal length can vary at the runtime, but the maximum length of the dynamic length of signals is needed to be specified at the configuration time. Of course, we are not going to do recursion or any other thing of memory usage. Okay, for any dynamic length signal, the com shall support com signal with one data type uint8 underscore dynamic. You're gonna see this in the configuration. And if you added another thing, you're going to get an error here. Restrictions, the type of uint array type also restricted the placement of dynamic length signal to byte boundaries. Okay, so all other signals potential, including the large signals, must be packed in front of the dynamic length. Why we need to put the dynamic length at the end of IBDU? Because if I didn't do this, then the com shall understand and take values or data which is not needed, since we have byte 1 signal and we have byte 2 and byte 3. This is the maximum length of dynamic length, and we have then byte 4 signal. He will have to take the whole 2 bytes, and this is not good for us. It's going to be waste of time, and we will take more data than what you need. Okay, that's why we always put the dynamic length signal at the end of the IBDU, and it always have, if it have an update bit at this point of time, we're going to talk about the update bit right now, but if it have an update bit, it has to be at the beginning of the signal. Okay, bit position number 0. Let's see what's going to happen. Actually, he is not recommending uh, sorry, he is recommending to use IPDUM module at this time of case if you have something dynamic, okay, as a multiplexing. And then let's see the transmission and the reception of this. What's going to happen here? The transmission of dynamic length signal or IPDUs, if it's dynamic, as we mentioned, RTE need to specify the actual length of the send. Then you're going to use here not com send signal, not com send invalidate signal, nothing like this. You're going to use com send dynamic signals. And by this API, you add to me the um, length of the signal, okay, with the signal value. So the com shall know from this what exactly is a signal dynamic length right now in the runtime, okay? But of course, if you added something exceeded the maximum length dedicated, it will gonna be a big issue. Okay, and here the com shall be able to send a dynamic length signal via normal or large IBDUs. Notice that it will need to send the length of dynamic, as we mentioned, to the lower layer. When com modules invokes PDUR com transmit for dynamic signals, the SDU length has to be last updated things, okay? And the reception of dynamic length signal and the opposite side, how he gonna know where exactly, what is exactly the dynamic length in bytes. So in the transmit, you call com send dynamic signal, you add the length, you add the value. But in the reception side, how he know this? He will gonna calculate the dynamic length of signals in byte by these equations, the received IBDU length in bytes minus the bit position of dynamic signal length, which is configured to his side, and he will divide it at 8. Why we do this? This is because that we saw last slides that it must be the update bit inserted at the beginning of your dynamic lens signals. So by this equation, it can help him to know where exactly the what exactly is the size of your dynamic lens. Okay, and we agreed also. Don't forget that this dynamic signal will be added always at the end of this PDU. Okay. Since the length of dynamic signal is derived from the received length of IPDU, then therefore COM does not support the combination with the dynamic length signal and IPDU's metadata. This is very important note also. Okay. And here we reach to the interface between the COM and BDUR. It's simple. We already talked about this. It's what's happening if you're gonna pass from the COM to the CAN TB or the CAN interface, you have to pass through the BDUR. So in case of I'm dealing with interface only and it's a single frame, I will see BDUR COM transmit. When I trigger transmit, COM transmit confirmation when I receive. The confirmation about my transmission is done successfully, and COM receive indication whenever I receive a new message, and COM trigger transmit to trigger it immediately. Okay, and in case of I'm dealing with a TB under the BDR, then I will see when I receive a large message, COM TB receive indication, and after this, it gonna start like start of reception first, and then you have copy receive data coming, and at the end you get receive indications. And if you transmit large data, you start about copy transmit data, and at the end you get COM TB transmit confirmation. Okay. This is for normal IBDU and for TB IBDU. Okay. And then this is the most important part. I think we could stop after the update bits because this is too much information. Okay. In the update bits, it's very important to know that um, it's one of the most important efficient way in the COM to save its time and to save the software time and to make it more efficient. Whenever we receive a data, how do I know that I received a data? Okay, or this data is updated, for example. I don't want to receive the same data every time. Since I have it already in the application, it's saved. I don't need it every time the same data. So please inform me if there is an update happening to this data. And by this concept, it's just to enable the receiver of a signal or a signal group to identify, however, the sender has updated this data from his side or not. Okay, this update bit, we specified it at the configuration where exactly um, it's happening, like, okay, where exactly this update bit is being checked. It's in the COM still. There is no access for this to that from the application side. So the application doesn't know if anything. Thus the COM will be configured and you specify the place where the update bit exists, which bit position, and he will check this. Okay, the update bit, whenever the transmitter side add this update bit to 1, it means for the receiver side that this data is updated, then the COM will take this data. Okay, if it's a 0, it means that this data is not updated and he can leave it as it is. Okay, so he will discard this data. Okay, so the as we mentioned, the update bit is not visible or accessible by AUTOSAR software components. 0, it means clear or data is not updated. So when I receive as a receiver the data and it was 1, it means that updated. I take the data, I clear the update bit for the next time reception. When I transmit the data, this data is new for me, then I put the update bit, I transmit it. Okay, and I clear it. And then when I if it's the same data, I will put it to 0 again. Okay, at the sender side, as we see here, comes in signal group, um, and here shall set the update bit of the signal groups. Okay, then we have com transmit b IBDU clear update bit of a transmit IBDU configured. Either you choose how to clear the update bits on transmit, so the com shall update clear it at the transmit of the BDUR com transmit when it's triggered by the com, and you can also use confirmation when the confirmation return back after the com trigger the BDUR com transmit, and trigger transmit all update bits of signal and signal group cleared after it's being triggered from the com also. Okay, so signal groups is being written by the application, and the com, if its transfer property was triggered, then the com do the same steps if according to the transmission mode evaluation of the IPDU, and then he will transmit it. If it's new data, he raises the update bit. If it's not new data, he skip the update bit 0. At the receiver side, he know what's happening there, and here he will choose what to do. If signal group or signal which is attached an update bit is received, the com shall process only the signals um, filter, any notification, any operation going to happen on this if the update bit is set. Other than that, it will be discarded and not routed, and that's it for this. It's also the init value or last received value will be returned when the application asks to read this data. Okay, great. Then here's data sequence control. I think we talked about this, and I think we could stop here at this point of time because this is a large amount of data, and we could also prepare another part two if it's needed uh, to complete the com. It's large things, but until now everything you saw is like 85% of what the com is doing, for example. So we can take some questions if you have. Okay.
Okay, thank you very much, Muhammad, for this comprehensive content. I really enjoyed the analogy you provided in the introduction. Thank you very much.
Thank you.
And as you mentioned, we could have part two. Let's discuss the possibility of such a thing. And
Mhm.
also, you mentioned that the slides would be provided.
Yes.
Okay, okay, thank you
Mhm.
very much. And for the maybe next 10 minutes, let's have a quick look on the questions. Um, okay,
Okay.
so the first question, not a question actually, it's a comment from Mustafa. He was
Uh-huh.
looking for an Arabic content.
Yeah.
Um, Let me explain the situation, please. So we are an international community. Our speakers comes from Egypt, Germany, even Brazil. So we cannot only target Arabic content or Arabic speakers. That's why it was difficult to do so. And I'm also recommending to have a look on the other live videos provided earlier in the embedded meetup channel. Thank you, Mustafa. And the next question is from knowledge page base. I think the question is related to the communication modes. He was commenting, or they were commenting on the
The trigger
none.
transmit, yes.
Yes.
None is for trigger transmit, right? It's sometimes you can use trigger transmit from the, as we mentioned, this is a signal transfer property, but what's going to happen if the transmission mode is none at this case? Yes, it will be triggered to be transmit at this case, yes.
Okay. Thank
Hmm.
you. We have a question from Hazem. He's asking about the decision taker or making of multiplexing signals according to the application or the SWCs.
Okay, if I understand you correctly, like if we are talking right now about the transmit mode evaluation, which happens, this is going to happen by the COM. But if you are talking about the multiplexing, which could be something for the IBDM example, this is another thing, another topic, I think. But the application has nothing to do with who is going to be taking the decision of the transmission. It's always in the basic software based on the configuration.
Okay. Uh, yeah. Also, regarding the maybe even the next
Uh,
webinar,
Yeah,
Vijay
AB
was
Trace's
yes.
AB Trace's configuration, it's gonna be crisis, yeah. But like I can tell to you, like I use always like I used DaVinci configuration. I use the AB Traces. Both of them are most probably the same, except for some other stuff like how it's generation, how is things happening there. But for the level of the com, it's most probably the same in the configuration, not the implementation, of course.
Okay. I also comment from my side.
Mhm.
Such industrial tools maybe is not easy to be covered in a public webinar. We need a license and some setup. So sadly, I think it won't be available in any webinar. Of course, maybe some webinar by EP directly, but not such setup like we are having today, Muhammad, and embedded meetup.
Yeah.
Okay, thank you.
Okay.
And also, we have another question from Knowledge Base. They are asking about the cooler of the COM trigger
Trigger
transmit.
transmit. It's gonna be happen from the application. Come send signal. Come send invalidate signal. Come send signal group array. Anything gonna happen through the RTE.
Okay,
Mm-hmm.
thank you. And
Welcome.
uh, so Muhammad, he is thanking you for the presentation. It
Welcome.
was smooth. Okay. Uh, and finally, we have Muhammad Meheri.
Okay, what exactly happens when the call, when the application call comes send signal to a periodic BDU signal? You mean a periodic BDU, not a signal. Okay. For a signal, configure the triggered signal. So at this case, if it's periodic, it's gonna be sent as a periodic. No impact for the trigger signal on a periodic. But if it's a mixed IBDU, as I mentioned, it's by default periodic, and no issue when you explicitly trigger a transmit request by this. If you mean like trigger transmit with an IBDU periodic.
Okay, and uh, finally, a question from Hazem.
Okay, it's not gonna be like this. This is multiplexing on the signal level. It's very hard. I didn't see this until now, but we can do this on the level of the IBDU itself by using the IBDU multiplexer module. And this is gonna be used actually after the BDR, and it's being routed into the comes through the BDR again.
And I think that's it. Uh, Hopefully, we will get another chance to meet with you. And
Great.
thanks again for volunteering to explain this important topic.
Great. Thank you, guys. And I hope you just get some information. It's not requested to get all of the information because this is something you get when you work your hand in your practical more. But it's the concept, it's the most important thing here right now.
Okay. Thanks very much for your time, everyone, and hope to meet you in another technical webinar. Thank you.
Great. Thank you. Thank you.
Goodbye.
Ciao. Bye.